Okay, we're going to go ahead and talk about multiplication of fractions, and you'll see some similarities here. Alright, first let's start off with the definition of multiplication, and this has to do with whole numbers. So given non-zero whole numbers m and k, if you multiply them together, we usually call that the product. So that is basically repeated addition. You have k plus k, and you keep adding k's until you get to however many k's you have, which is indicated by m. So it's just k plus k m times. So the definition for fractions, the product or multiplication of two fractions, k over L times m over n, is by definition the length of the concatenation, again repeated addition, of k of the parts when the segment 0 to m over n is partitioned into L equal parts. Now that should sound familiar because it is the same definition as fraction of a fraction. Therefore, if you have a fraction times a fraction, that is the same as saying k over L of a segment of length m over n, which is, you can recognize those ofs in there. That means that k over L times m over n is the same as k over L of m over n. Alright, so if, let's say that L and n is equal to 1, then this definition is going to say k over 1 times m over 1 is the length of the concatenation of k of the parts when the segment 0 to m is partitioned into one equal part. Well, in other words, it is the length of the concatenations of k copies of 0 to m, but that's exactly what whole number multiplication is. K times m, which is m plus m, however many k times is in this case. So as you can see, multiplication of whole numbers is directly related to multiplication of fractions. It's just a whole number is a fraction with a partition of 1 or a unit segment of 1. So what's the connection of this? Well, let's go back to division when we talked about fractions as division. We stated that if we have some number k, or some whole number k divided by into equal L parts, we can stop using the division sign and write that as a fraction, k over L. Well, we've also defined k over L as being k copies of 1 over L, partitions of L in this case. So it could be said that they are k times 1 over L. Well, if that's the case, then division, k divided by L, is the same thing as saying k, it's actually the same thing as multiplication, except now it's k times 1 over L. So you can rewrite division problems as multiplication. Another connection, if k is a whole number, then k times m over n is equal to k over 1 times m over n, so that k times m over n is just repeated addition of fractions. It's just m over n added several times, however many times is determined by k. So that is just repeated addition, or again our definition, k copies of m over n. Alright, so this is what we call the product formula theorem. Product meaning multiplication. So if you have two fractions that are being multiplied, then essentially you do the same thing as fraction of a fraction. You multiply the numerators and multiply the denominators. The cancellation rule for fractions comes from this, where now we can simplify or put in simplest terms. So let's look at the example, 135 over 28 times 49 over 9, and it's going to equal 105 over 4. Well, on the left side, we can restate 135 over 28 times 49 over 9 as 135 times 49 and 28 times 9. Well, we can also rename this, because it is still the same point on the number line, by using the equivalent fractions theorem. We can state 135 as a factor of 15 and 9, and 49 as a factor of 7 and 7. And then the same thing with 28. 28 is 4 times 7, and then we have 9. Well, through the cancellation law, you can cancel out the 9s and the 7s, and you are left with 15 times 7 over 4, which is 105 over 4. So if we multiply the fractions k times a over L and m over n times a, where all these symbols are whole numbers, we can cancel the a's to get k over n, or k times m over L times n. So let's practice on this. I want you to go ahead and try to find the value of 11/14 times 2/33 in simplest terms. I want you to, each step that you write of the process, I want you to write the theorem that you are using. Go ahead and try this on your own before you continue the video, because I will show you the answer next. Okay, so first of all, you start by writing the original problem, which is 11/14 times 2/33, and we can also write that. An equivalent way of writing that is using the product formula and putting all the numerators on top and all the denominators on the bottom and multiplying. So showing that 11 times 2 and 14 times 33. Well, from here I can factor my numbers, not anything on the top. The numerators don't have anything to factor, but the bottom I can write 14 as a factor of 2 times 7, and 33 is a factor of 3 times 11. From here, I can use the cancellation rule for fractions, and the 11s cancel out and the 2's cancel out, and I'm left with nothing on top except the fact that I have 1. Because remember, 11 times 2 can also be multiplied by 1, and so that is what is left. And then at the bottom, I have 7 times 3. So now I can finish simplifying that and come up with 1/21. All right, we'll go ahead and practice these in class.